In this lesson, we're going to look at how to solve polynomial equations, which is exactly the same process that we were using when we were finding the zeros of polynomial functions. It's exactly the same, except for a little vocabulary. Equations have roots or solutions. Functions have zeros. So where we used to say, let's find the zero of the function, now we'll say, let's find the root of the equation. But it's the same process used throughout. So we're going to look at how to solve x to the third minus 2x squared minus 11x plus 12 equals 0. And again, just note that our previous factoring methods that we learned earlier in the semester would not do the trick here. We don't have any factoring methods that would let us tackle something like this. So the only way to get at it is to make a P over Q list. So here are my P numbers, all the factors of 12. And my Q numbers are just all the factors of 1, so simply 1. Then P over Q is every one of these over 1, so they all stay the same, but I have to consider the positive or negative value of each one. Now, which of these numbers are actually roots of this equation? The only way to find out is to start doing the synthetic division. And here I've already started a synthetic division with 1, and I find that 1 is a root. The way I know that is I have a remainder of 0 here. So x minus 1 goes evenly into our equation, therefore 1 is a solution. Alright, so now I've succeeded in breaking this down into two factors. The x minus 1 that I know from here, and the other factor is x squared minus x minus 12, which I see here. And if I can factor this, which I think we all can do with no trouble, then I can see my three solutions. I'll get 1 and 4 and negative 3. And these are the solutions to the equation. Alright, here's one more. Let's solve 6x to the third plus 25x squared minus 24x plus 5 equals 0. So again, I know that I cannot solve this by factoring alone because it won't factor, but I can make a list of P over Q numbers and see which things might be solutions. So 1 and 5 are the factors of 5. Then 1, 2, 3, and 6 are the factors of 6. And every P over Q combination we can make will be a possible rational solution. Here you see each of the denominators under the 1. I've got 1 over each of these denominators, and here you see 5 over each of my denominators, and I have to add a plus or minus. So this whole long list is my list of possible rational solutions. So let's just start with 1 and see if 1 might be a solution of this equation. And I find no, it's not, because I see that 1 leaves me a remainder of 12. Okay, so 1 is not a root. Could negative 1 be a root? Well, we run the synthetic division and we find out no, negative 1 is not a root. Alright, let's try 5. And if I run the synthetic division with 5, look, I did not even finish it because I could see it wasn't going anywhere good. Negative 24 plus 275 is going to be a great big number. That number times this positive number, no way is going to make this add up to 0. So I just gave up and said, well, 5 is not a root. Let's try negative 5. Okay, finally we get some good luck with negative 5. When I do the synthetic division, I get 0. So negative 5 is a solution. That means x plus 5 is a factor. And the other factor is 6x squared minus 5x plus 1, which you see here. So basically, this synthetic division let us perform factoring that we could not previously have done on this 4-term expression. And so now all I have left to do is factor this trinomial. Alright, so 6x squared is going to be 3x times 2x. This tells me that the signs should both be the same, and this tells me they should both be negative. Alright, and then 1 times 1 is the only way to make 1. If I check outer plus inner, make sure that that's adding up to negative 5, then these two factors make this trinomial. We're in good shape. And each of these factors is going to give us a solution. If x plus 5 is 0, then x is negative 5. We had already found that one by synthetic division. If 3x minus 1 is 0, then x equals 1/3. And if 2x minus 1 is 0, then x equals 1/2. So our three solutions are negative 5, 1/3, and 1/2.